Europe, 80,000 years ago. For countless generations, the kingdom of a remarkable and mysterious creature. Neanderthal. A species of human, in many ways so similar to us, and yet also very different. We've brought together a crack team of experts to recreate Neanderthal in unrivaled anatomical detail. We'll discover exactly how modern humans would have stood up against our ancient rival in strength and endurance, and how Neanderthals might have compared to us in intelligence and inventiveness. At the end of it all, we'll be able to answer some of the great questions of human evolution. Was Neanderthal the simple-minded brute of legend, or a rival to our own species? And why is it that today we are the only species of human alive, and the Neanderthal is extinct? Like so many of the best stories, the saga of Neanderthal began with a chance discovery. In 1848, a strange skull was discovered on the tiny military outpost of Gibraltar. When it was first revealed, it confounded everyone who saw it. There was no doubt it was human, but it also had the heavy features of an ape.
This is the actual skull found in Gibraltar. The first recognisably distinct primitive human ever found. This was an extraordinary find, and people didn't know what to make of it at that time.
It was the beginning of a legend. What was this ancient creature, and when had it lived? Soon, one thing at least became certain. It had not been alone. Remains of the savages were being found all over Europe. From the Atlantic coast in the west, almost to the foothills of the Himalayas in the east. They were everywhere.
We find Neanderthals right across Europe. They've evolved there for over 200,000 years. And then 30,000 years ago, we lose them. There are no more Neanderthals. They've gone.
And this has been the mystery ever since. From the fossil record, it seemed that these extraordinary creatures had suddenly just disappeared. When scientists looked for a reason, one possible answer soon emerged. The Neanderthals had died out, just as our species, modern humans, had arrived on the scene. And so an epic saga began to be told of how our big-brained ancestors emerged from Africa and spread into Europe, wiping out the primitive, inferior Neanderthals as they went.
The conventional idea is that modern humans encountered the Neanderthals and outcompeted them. They were better at doing everything. The Neanderthals just died out because they were replaced by a superior species.
But was the traditional theory actually true? Was Neanderthal really the simple-minded brute of legend, or not? The task of our team is to find answers. Before our experts can begin to investigate, they need a body. But no complete Neanderthal has ever been found. To solve this problem, the first of our team to be needed is Gary Sawyer, our reconstruction expert. Working at the American Museum of Natural History in New York, he has rebuilt the appearance of countless ancient humans from their fossil remains.
No complete Neanderthal skeleton has ever been recovered. My dream has always been that I can somehow gather together as many good casts as I can and see if it is possible, if it is feasible, to make a complete skeleton. Here is where a little Frankenstein work is going to come in real handy.
Horizon's Neanderthal will be a composite of many sets of remains, all to be donors towards the most complete Neanderthal skeleton ever assembled. The core of the skeleton comes from a Neanderthal who lived in Israel 60,000 years ago, called Kibara.
We've got collarbones, shoulder bones, upper arm bones, hands.
A 50,000-year-old Neanderthal called Le Pharisee from France will give our skeleton a skull and other key parts.
This is La Pharisee, or La Pharisee 1, classic Neanderthal, complete with lower jaw. The very parts that are missing in Kibara, present in La Pharisee.
Finally, remains from a German Neanderthal will provide our skeleton with his arms and legs.
We have lots of limb bones. Unfortunately, they're incomplete. So it's going to be necessary to do a lot of transplant surgery.
After a year of shaping and matching Neanderthal bones, the final pieces were coming together. Our investigation could begin. To study our skeleton, we've brought Trenton Holliday, an expert in Neanderthal body proportions, to New York. He's spent a career studying their bones in isolation. Now, he's about to meet the world's first complete Neanderthal.
This is the guy.
Did a great job, Gary.
Yeah?
Did a great job. I love it.
And it was no cakewalk doing this guy.
No, I imagine not. It's fantastic work.
La Pharisee clavicles.
Oh, yeah.
And the feet are primarily...
The thing that amazes me is I've studied all of these pieces individually, but until you see it put together in this fashion, articulated like this, it really gives you an appreciation for the Neanderthal as an individual.
From the shape of the skull, Gary and his team meticulously recreate the face of our Neanderthal. And using Gary's scientific recreation as a template, we were able to bring our Neanderthal to life with startling anatomical accuracy. The skeleton reveals our Neanderthal to have been an extraordinary creature. He stood no more than 5 feet 4 inches tall, but he had an immensely powerful build. Our team's hope is that this skeleton will provide answers to those great questions. Was Neanderthal a simple-minded brute? And why is it that we're here and he's not? For Trent and Holliday, one of the most striking features is the skeleton's rib cage.
What I find amazing about the rib cage reconstruction is, if you notice, the ribs continue to flare out as we go inferiorly. This is something that doesn't happen in humans. In humans, the ribs start to come in again, and we have what we refer to as a waist. It appears that this Neanderthal did not have a waist. One explanation for the shape of this rib cage and for the overall shortness of the limbs and the compactness of the body is that it's related to cold adaptation, that a short, compact body with a voluminous chest is going to help retain heat better in a cold environment.
The theory certainly makes sense. Neanderthal lived during one of the toughest periods in human history. The last ice age. During this time, the climate of Europe varied enormously, but it was characterized by periods of intense cold. At its worst, most of Britain was blanketed by polar ice over a mile thick. For hundreds of miles to the south, there was nothing but desolate wasteland. Life in the north would have been impossible. But it seems that further south, where the frozen tundra began to melt, Neanderthals could survive. Living on the fringes of broken woodland. To exist for so long, in such harsh conditions, most scientists believe that Neanderthal must have been biologically adapted to the cold. But the idea that the strange ribcage was connected with cold adaptation was only... To find out for certain if it could really have helped survival, our team will conduct an experiment. Leslie Aiello is an anthropologist who has studied how Neanderthals survived the last ice age. We brought her to Loughborough University to team up with George Havenith, a human biologist who runs a high-tech lab, to study how the body regulates heat. To help them, we've recruited 2 volunteers with different physiques. Will is going to represent our ancient human ancestor, while Gary has a build much closer to that of a short, heavily muscled Neanderthal.
For our experiment, we've selected 2 people who are representative of the 2 groups we want to study. One person with a big muscle mass, as you will see, bodybuilder shape, and one person with more like a runner type shape. Okay, so that goes in your ear.
What we're doing here is trying to find out whether the Neanderthal body form is really an advantage in terms of keeping the Neanderthals warm.
Gary and Will are wired with temperature sensors that will measure how well their bodies cope when they are subjected to extreme cold. In this case, an ice bath.
Okay, is that okay? Okay.
As their bodies start to react to conserve heat, information from the sensors is monitored.
Is the data coming in?
It looks like it, yes.
Okay, excellent.
Under stress, both bodies divert blood away from the skin, circulating it deeper to keep vital organs warm.
Will does seem to be getting considerably colder than Gary here.
Yes, I think we can clearly now see a separation between the 2 core temperatures, where Will is definitely cooling down a lot faster.
In the bath, Will, representing our modern human, is beginning to hyperventilate. One of the first symptoms of hypothermia.
Pretty cool.
But Gary, whose physique is more like that of a Neanderthal, is faring much better. After about 25 minutes, it's decided for Will's safety that he must get out of the bath, and the experiment is ended. Back in the lab, a thermal imaging camera is used to detect the skin temperature of our 2 volunteers.
Let's have a look at the picture. Oh, that's excellent. So what we clearly see, we've got the muscular person here on the left-hand side and the more athletic person on the right-hand side.
The light areas show where most heat is being lost. And significantly, the darker area around Gary's chest shows that his body heat is being retained much more efficiently than Will's.
And we see clearly that the muscular person has a lower skin temperature than this athletic person.
So being relatively heavily muscled is a real advantage.
Yes, definitely. The muscles, when they're not active, they will actually act as an insulator to the body core and therefore prevent heat being lost to the environment.
So it does seem that the deep, wide shape of our Neanderthal's ribcage would have helped him to survive during the Ice Age. It would have supported a thick layer of muscle, giving him both strength and insulation. But our Neanderthal's powerful body came at a cost. To survive, he would have needed a lot of calories. And that meant meat. To find out just how Neanderthal got his meat is another challenge for the Horizon team. Our body plan expert, Trenton Holliday, is going to be looking for more clues in the bones of our own Neanderthal. But we've also recruited 2 new experts, hunting specialist John Shea and anthropologist Steve Churchill.
Neanderthals were people on the go. They were literally wrestling their environment. To Neanderthals, living in cold glacial environment of Europe was a situation of living on the edge. Neanderthals had to capture enough calories to stay warm without at the same time expending too many calories. And this is an expensive body type that we're talking about. Very muscular, very active kind of body, requiring a lot of calories.
The archaeological record suggests that Neanderthals hunted on the edges of forests, preying on large animals, like red deer. A group of Neanderthals needed to kill one of these every 2 days to survive. That's about twice as much energy as we need today. To hunt effectively, they needed weapons, and they left behind a wealth of well-crafted stone spearheads.
This is a classic Neanderthal technology. This is the way they made stone tools for nearly 250,000 years. I strike, and pretty quickly, you have a very large, sharp, and thin flake that can easily be transformed into a Neanderthal stone spear point.
By recreating Neanderthal spears and experimenting with them, John Shea has discovered something significant. If Neanderthals had hunted in forests, then the heavy spears they made would have had a major limitation. They couldn't be thrown.
This is the kind of dense woodland environment in which Neanderthals did a lot of their hunting. Now, you can't throw a weapon like this very easily in woodland because all you would need would be a glancing blow against a tree or impact against a branch. And you might break the tip of the spear, in which case the spear is useless, or it's going to lose energy. And if it loses energy and hits the animal with anything less than lethal force, the animal's going to run.
So if he didn't throw his spear, how exactly did our Neanderthal hunt? Analysis by our bone expert Trenton Holliday suggests there's a hint in the skeleton.
When we look at this individual, looking at the left arm, it's muscled. It's nothing to sneeze at. But moving around to the right arm is quite impressive. The muscle markings are much more clear, indicating this individual was very powerful on the right side, more powerful than on the left. When we move down to the forearm, we see something that is really extraordinary. Notice the curving or the bowing of this radius. This corresponds to powerful muscles that flex the wrist and flex the fingers, such that Neanderthals had a very powerful grip. Even the pinky has flexor ridges that show that the pinky was just as strong as the other fingers, making for a powerful grasping hand.
So the bones show that our Neanderthal had one arm far stronger than the other.
And go.
Excellent.
To see how this difference in arm strength might have related to hunting, anthropologist Steve Churchill has devised an experiment.
Get the gauges.
One possibility is that they're getting that kind of difference in strength from side to side through thrusting spears. And by thrusting this into something, we can tell how much force is going to each limb that the spear thruster is using, and we can actually determine if this two-handed behavior is in fact stressing one limb more than the other.
The data from this experiment shows that thrusting a spear could explain the marked difference in muscle development from one arm to the other. And especially the extreme power of our Neanderthals' right forearm.
So it turns out what we found from this experiment is that in fact you can get differences from side to side with a two-handed behavior. In my case, and in most people's case, the left hand was used as a guiding hand. The dominant limb was used to provide the force of the thrust, the drive.
Evidence from the skeleton and the spear itself suggests that Neanderthals were ambush hunters, silently stalking their prey. Creeping with a thrusting spear to within striking distance. Here was a carnivorous predator with an insatiable hunger for meat. From the evidence so far, our Neanderthal was shaping up to be the brute of legend, just as the traditional saga had told. So did this mean that he really was inferior to modern humans? Our simple-minded, primitive cousin.
The traditional view of Neanderthals is one where they're thuggish, brutish, strong, powerful, had to be in order to survive in the harsh environment. The question we need to ask ourselves is this view correct? Or have we been missing something about the Neanderthals and their essence or their nature?
So the next task for our team is to search the skeleton for evidence that could reveal more than just his muscles. Somehow, they need to get inside his mind. To investigate whether our Neanderthal might have been simple-minded or intelligent, we've recruited Ralph Holloway, an expert in the anatomy of ancient brains.
The human brain is what we are. It's responsible for all our feelings, our intellect. But the problem is that the brain doesn't preserve. So what one has to do is very judiciously take what one has and try and make the most of it.
The brain of our Neanderthal no longer exists, but the inside of his skull does contain impressions of how it was shaped. By making a cast of this imprint, Ralph Holloway can recreate what was once inside.
The first thing that really grabs your attention, I think, is its size. It's much bigger, and significantly so, than the normal modern human Homo sapiens brain.
Measuring the volume of our Neanderthal's brain shows it to be 20% bigger than the average for a modern human. But size isn't everything. Could Ralph Holloway detect any details that might suggest whether it was as sophisticated as ours?
First of all, it shows the same kind of cerebral asymmetry as any modern right-handed human being would show. So this is a right-handed individual. The second thing you can tell about it is the shape of the frontal lobe is really absolutely no different than what you find in a modern Homo sapiens. So the prefrontal portions that are supposed to be dealing with very complex cognitive functioning and so forth, they're about identical between Neanderthals and modern Homo sapiens. So this I think should lead to the idea that basically their cognitive abilities are the same as our own.
Despite the strange shape of his head, it seems that our Neanderthal's brain was anatomically identical to our own. This means he could have thought like us. But it doesn't necessarily mean that he did.
Him, and immediately...
Modern humans don't just have complex brains. We use them in a very particular way.
Read my lips.
We communicate using sophisticated thought and language.
Yes, I tried to speak to her.
It's an ability that has been crucial to our progress, ever since our ancestors spread out of Africa.
Thanks very much, thank you.
Without the power of speech, our Neanderthal, for all his big brain, would have been inferior. So now the question was, could he talk? Even here, our skeleton contains a clue. A tiny bone called the hyoid.
Here's the hyoid, the only Neanderthal hyoid known, and this is where it fits. The hyoid could be related to language. The problem is knowing what else surrounds the hyoid in this region. That's what we would really need to understand in order to know what Neanderthals sounded like, if they spoke at all.
So Horizon has set another challenge. Bob Franciscus is an anthropologist who specializes in Neanderthal noses and throats. And Patsy Rodenberg is one of the world's top voice coaches. Together, could they tell us if our Neanderthal spoke?
We'll raise you up and then slide you into the machine.
Bob Franciscus begins by taking medical scans of living people to make images of their throats. This is the first stage in reconstructing the missing soft tissue of a Neanderthal vocal tract.
The resolution is really high. The challenge really is, how do we get at soft tissue form from the skeletal remains?
Scans like this build up a detailed picture of how modern human throats are shaped by the position of our hyoid and other bones.
The importance of using a modern human sample is that we have both the soft tissue, which we're primarily interested in, but the bones that surround it. And we can use this positional information between the two to predict the soft tissue from the bones.
The next stage is to use this data to develop equations that could recreate a modern human vocal tract.
This is a model of the portion of the tube right about here, and it would fit just about so.
The same equations can then be applied to measurements from our skeleton. What finally emerges is a model of the vocal tract of a Neanderthal.
So this is the result. The Neanderthal tube is quite a bit shorter, and it's quite a bit wider from front to back. The shortness of the tube is much more akin to what we see in recent human females.
So there's no doubt that our Neanderthal had the anatomy necessary for speech. But what would he have really sounded like? That's the task for our voice specialist. And Patsy Rodenberg has just been given the newly created vocal tracks.
Oh, goodness, that's very interesting. This is a human. This is a human throat. This is a Neanderthal, and it's very squat. Probably the voice would be higher. So, Elliot, let's try male human voice, count over 3.
1, 2, 3.
Just pitch up your voice.
1, 2, 3.
Now, we might have an idea that a macho sound is low, but that might be very useful, but it gets even more complex.
As well as his vocal tract, our Neanderthal's strange shape would also have affected his voice. His deep rib cage, a large and heavy skull, and most of all, a huge nasal cavity.
Let's just add a bit of nasal now.
1, 2, 3.
Now, the other thing that would be happening, which would actually increase that quality, is a very heavy skull that seems to pull down into the throat there. Now, add to that the fact that they had a fantastic chest, which is a support system of breath, which can produce enormous chest resonance and tremendous power. So I imagine that they wouldn't have subtle sounds. It would be loud, or very, very loud. And we can try and get that by... I'm now going to engage Elliot by push into me. This is actually getting him right into his body. Now, speak.
1, 2, 3.
Now let's make a sound. Just let's make a huge R. And again.
So the skeleton had shown that our Neanderthal wasn't just big-brained. He also might well have spoken. It seems that he wasn't the primitive ape-man of legend after all. Powerful, adapted to the cold, and now it appeared, intelligent. The conventional view that our ancestors had wiped out the inferior Neanderthals surely had to be wrong. In the world of Ice Age Europe, he should have been invincible. Our investigation was only deepening the mystery of Neanderthal. If he hadn't been killed by our superior ancestors, just how had he become extinct? There is one big clue. Before modern humans had arrived, something happened that transformed the Neanderthals' world. There was a sudden change in the weather.
Around 45,000 years ago, the climate in Europe begins to deteriorate significantly. It begins to get colder, it begins to get drier, but there are also bigger changes. The changes are more rapid. It's changing very, very quickly. It's going from one thing to another, back again. It's not settling in any particular way, and it's getting worse and worse and worse.
Neanderthals were built to survive the cold, but the speed of this climate change was different to anything they had experienced before.
It's not at the scale of thousands of years. Sometimes it's at the scale of tens of years or hundreds of years, within generation times of Neanderthals.
Neanderthals faced a crisis of survival. The forests in which they lived were dying out because of the weather. And in this new, more open landscape, they would have found it increasingly difficult to hunt.
Away from the woodland, Neanderthal spears like these are useless. Any animal with half a brain is going to have run long before that spear hit the ground. Works great in the woodland, but if you're in open steppe environments, it's not a very effective hunting weapon.
Neanderthals were already facing problems because of the changing weather when the first modern humans arrived in northern Europe. And they came with a new technology, a much lighter spear that could be thrown.
Out in open country, modern humans needed a weapon that was effective from a distance. And this was one of their solutions. This is a spear thrown with a hooked stick. This is essentially a stealth weapon. You can throw this kind of dart at an animal tens of meters away and it won't hear it coming. If the first sign it has that it's under attack will be the spear hitting it.
With projectile weapons, modern humans could hunt on the open plains far more effectively than Neanderthals. Striking prey with deadly precision. Of course, our Neanderthal could have adopted this new technology, but this in itself would not have been enough. The new hunting methods also required much greater mobility to track herds on open ground. So now the question was, could our Neanderthal have measured up against his new rival in speed and agility? Once more, our skeleton contains a clue. A tiny relic of one of the smallest and most sensitive parts of the body. His inner ear. To analyze it, we've recruited Fred Spoor, an expert in anatomical evolution.
Inner ear, you would think, oh, hearing, and that's correct. You do perceive sound there. That's how you hear. But the other part that is really interesting are these little canals that you see over there. They're part of the organ of balance.
By studying different animals, Fred Spoor has found that their inner ears vary, depending on their level of agility.
When we study mammals and we study birds, we find a very close relationship between the size of the semicircular canals that are part of the organ of balance and their behavior. The more agile, the more acrobatic you are, the larger the canals are.
When Fred Spoor looked at the inner ear of modern humans, he found relatively large canals, an indicator of high agility. But when he turned to the inner ear of a Neanderthal, he found that the canals were significantly smaller. Not only compared to modern humans, but also to even more primitive ancestors.
When you look throughout human evolution, the canals that actually measure the movements that you make become larger and they become more sensitive. But then with Neanderthals, the canals become smaller again. And that is really the odd one out, the only one I've ever encountered, and really surprised me. The only logical conclusion is that Neanderthals were less agile and probably didn't include so much jumping and running in their general behavior.
So in one crucial respect, the agility needed to run and jump, our Neanderthal was inferior to our ancestors. And there was a reason why. It seems that his body plan simply wasn't that of a runner.
What characterizes all Neanderthals are these extraordinarily short lower limbs, built for power, not so good for speed, not so good for long-distance running. And if we move up from these short limbs into the pelvis, what we find is a pelvis that itself is extraordinarily broad. This means the pelvis is not going to be as biomechanically efficient in long-distance locomotion as our own.
It seems that the very features that made Neanderthal perfectly adapted to the rigors of the Ice Age had also locked him into an evolutionary dead end. Modern humans may not have been adapted to the cold, but they were tailor-made for the open plains.
It's kind of ironic. Neanderthals were adapted to the cold, but that's not what made the difference. Modern humans were better able to exploit the open spaces, the steppe habitats that were expanding in Ice Age Europe. And as the forest retreated, the Neanderthals retreated along with them.
Unable to survive in the open, Neanderthals could only have clung on in ever-decreasing woodland refuges. And as their habitat collapsed around them, their population fell.
The effect on their population seems to be that the populations that were once closely connected across Europe begin to get fragmented and scattered. There comes a point around 25,000 years ago that these populations are no longer viable and the Neanderthals disappear from the planet.
All in all, our skeleton tells a classic evolutionary tale. The traditional saga of superior modern humans wiping out the primitive and inferior Neanderthals may well be wrong. Instead, the answer to that age-old question of why we are here and Neanderthal is not may come down to something much more random. Environmental change and the twists of evolutionary fate.
And it's survival of the fittest at Wimbledon with coverage of the ladies' singles semis in 10 minutes on BBC Two.